Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're going to be taking a look at these Lucas Deeco Seal Touch terminals. These are industrial touchscreen serial display terminals with gas plasma screens inside. And they are die-cast, very sturdy, designed for hooking up to like CNC milling machines, things like that. The date on the box is 1992. One of these actually works and the other one does not. So in this video, I'd like to take a closer look at this working terminal, see what it's all about, see the gas plasma screen in operation, and it is a touch screen with an on-screen keyboard, but also supports an external keyboard, and then take apart this non-working unit, see if we can figure out what's wrong with it and maybe get it working again. So without further ado, let's get right to it. Now everything about this terminal screams industrial. The entire thing is die-cast metal. And if you flip it around to the backside, you'll notice the giant heatsink for the fanless operation of this thing, almost certainly designed to run 24/7. I mentioned this was a terminal, and it absolutely is. It's an RS-232 terminal, but also supports other protocols as well, RS-422 and 485, if I recall correctly. This particular unit has an IEC mains input, and this odd connection, if we pop the cover off, this is actually the keyboard connector. According to the manual, there are other variants of this with different locking style power connectors or DC options as well. Embedded into the heatsink are 4 mounting holes. The bottom of the unit also sports 2 different holes for mounting. Now, one thing that's really interesting about this thing is it's unbelievably dense. The manual says this weighs just under 14 pounds. But my assumption is the extreme heavy build quality and sturdiness of this just comes with the territory for a device like this, which probably costs an inordinate amount of money. And the wild thing is even though this thing is from 1992, at least from the box, I bet you there are still plenty of companies out there using this exact same device for operating their industrial machinery. For us to try to figure out a little bit of information about these, the manual should help. Now, one thing you might notice is this says it's a graphics terminal. And I didn't really mention this, but indeed, this display, beyond just supporting VT100 and VT220, has some type of vector display mode where over the serial port can actually draw full-on graphics and also use the touchscreen as an input device. It appears that the protocol that the terminal uses is specifically called the ST3220 protocol, and it's overlaid on top of the normal ANSI protocol, which is shared by the VT100 and VT220 coding, which seem to give the terminal a bunch of capabilities like graphical text, polygons, and vectors. Everything supported on the terminal is fully explained in the manual, so that's handy. I'm not sure if this has been scanned. If it hasn't, I'll make sure that this gets uploaded to archive.org. The touch capabilities of the terminals described on this: 27 Hz refresh rate and an 80 by 50 touch resolution. Here are the technical specifications for the terminal: 13.6 pounds, 640 by 400 resolution. XY coordinate reporting, up to 120 pages of 120 buttons, pop-up menus, on-screen keyboard, touch sensitivity, 16 kilobytes of RAM standard, 64 kilobytes optional, non-volatile, RS-232C, 422, and 485, serial printer, and AT keyboard interface. A full pinout for all the ports on the device, so the RS-232 port, the printer interface port, which is the DE9 that's on the back, and the odd keyboard interface, which is standard AT keyboard, as it mentioned earlier in the book, but does have this unusual connector. Mechanical interface drawing, so you can mount your terminal onto whatever device you need to use it with, and a full feature comparison of all the terminal's features when in VT220, 100, and the ST3220 modes. And it's that special 3220 mode which supports the display list, the graphics mode, the raster operations, including DMA read and write. Interesting. And it appears that this thing actually supports some non-volatile storage of retained graphics frames. So I assume you can set up menus and things, and that actually is contained in the device, so it doesn't need to get uploaded into it each time you power it on. Appendix J outlines some of the diagnostic modes available on the device, so it does have a self-test or a power-on self-test that runs, and there is a reported failure code, so that might be helpful in trying to figure out what's wrong with the broken one. And the rest of this I don't think is too relevant to what we're doing here. Yeah, that's it. And leads to the publication of this manual. That's Lucas Deeco's address and phone number. No idea if they're still around or still based in Hayward, California, which is up in the Bay Area. So these terminals come from my friend Dave, who apparently back in the day had procured a bunch of these for a good price, and then slowly over time had been selling these on eBay, probably to companies who use these for their industrial machines and needed a replacement. I'm not sure if people are still looking to buy these, but Dave told me they started having a bunch of these where they started failing, kind of like this one has done. And he ended up giving me one of the terminals that works with the hope that we could try to compare some of the working voltage rails or whatnot with that one and the broken one. Now I have to admit, I've had these for a while, but I did just unbox these just today, and I noticed the broken one, which is this one, has some concerning discoloration on the plasma display. Let's swap this out for the working one so I can at least show you how it's supposed to work. All right, so this is the working unit, and notice that it maybe has the slightest of discoloration in the corners. That was a little bit of the camera auto gain that was just happening there, but the middle looks pretty good. Now, in order to try to film this, I need to power it up while it's lifted off the bench a little bit. So I'm gonna put a piece of wood behind it. Hopefully I can get the power cord inserted. Okay, on power up, we get a power LED. And there we go, self-test, configuration, memory, something like that, and a flashing cursor. It boots up very quickly. Now, if we touch in the lower corner, I found that we have a pop-up keyboard. Check out that glorious plasma display. And yeah, it looks really good. This unit, at least, I don't think has ever been used because the screen looks to be in absolutely perfect shape. Now, apparently there's a configuration menu somewhere on this thing. There it is, setup. Ooh, module setup version 13.0. So it's a very subtle beep when I push the touchscreen, at least on areas where there are buttons. So let's just quickly look through all these options. So clear screen, push enter. Okay, this is pretty much normal stuff. Display, auto wrap, cursor, cursor style box. Assume it's box or, oh, no, I guess we push enter to select things. Underline or box, screensaver on or off. Printer prints the entire screen, I suppose, maybe with a print screen key, probably something like that. Print to host, I guess it can also print the screen back over the serial port. Some simple keyboard functions, pretty self-explanatory. And then we have a communications menu. I think the network functionality has to do with the RS485, which allows for unit IDs, nodes, and things like that, like multiple devices on the same serial connection. But RS232 just has a simple baud rate up to 38.4. Data bits, parity, all the usual stuff. I/O type, yep, 485 2-channel, 45 1-channel, parallel. I don't really get that. Or RS232, oops. The touchscreen is very, very sensitive. So actually, you know what? It's infrared. Because I didn't even touch the button. I didn't even touch it at all. Let's get something to block the beam. Oh yeah, I'm not even touching this screen. If I tilt this over, you probably won't be able to see, but I'm very close, but not touching it. So the way these would work is there's a bunch of LEDs maybe on 2 of the edges and a bunch of receivers on the other 2 edges, and you put your finger in a position, it blocks this beam and that beam, and using that can triangulate exactly where you're touching. Now it looks like we have some additional functions like XY track, XY exit. Don't know what this stuff does. Let's exit out of here. Oh yeah, look at that. Huh, that's interesting. I assume it's sending the coordinates of where I'm touching back over the serial port to the host device. Isn't that interesting? Let's try to trick the screen. Yep, there we go. Tricking the screen by blocking the sensors. Fun. And if you have one of these things to enter the menu, you just touch in the lower corner. There's the on-screen keyboard. Nothing much to say about that, but we click on pad and then you have your setup feature. Now there's a lot about the way the plasma screen looks on the edges, and I'm sorry for the auto gain on the camera. Don't know how to turn it off on my bench camera, but a lot about this looks very similar to the plasma screen I had on that one laptop. I think it was a Samsung, and it had lines in it. And I think the plasma screen was coming apart in the bond areas, and there was really no way to fix that. And I'm hoping that's not the problem with the other one. This one appears to be perfect. I mean, we can't see yet because we haven't made this whole screen just turn solid white, but judging by the fact that the on-screen keyboard has no vertical lines in it, it probably means that this screen on the working one is in perfect shape. When searching for Lucas Deeco, the name of the company, on Google Images, this is literally all you get. Not a whole lot, although we do have some pictures of some of the terminals and some other versions, like one with a handle, and one in a case with a different badge. And here's a picture of one of the Seal Touch devices that I'm working on today.
Google search turned up a couple patents that seem to relate to the touchscreen device we're going to see inside of this terminal. And interesting is you'll notice it says application filed by Digital Electronics Corp. It looks like the name was changed to Lucas Deeco in 1992, at least with the patent office. And it was changed again to Lucas Automation and Control Engineering Incorporated, and then the patent expired. And then there's a second patent, which seems to be of similar technology, at least talk a little bit more about how this thing works. Same thing, Digital Electronics Corporation, Lucas Deeco, Corp of CA, and then Lucas Automation and Control Engineering. I found this webpage from Control Systems Integration Inc. It seemed to be a company that was probably a contract company that made interface solutions for various industrial applications. And it seems that a California wastewater company was one of their clients. And they seem to have created some kind of interface for a SCADA system, a control system, that used two of these Lucas Deeco object-oriented touch screens for control of these PLC devices. Continuing the search, it seems that Wayback Machine has captured the Lucas Deeco or the Deeco Systems or the Lucas whatever control systems webpage right before it died. It seems that a squatter picked up the domain, and going forward in time, it seems that Deeco Incorporated is now some company that makes some kind of air quality monitoring stuff. Poking around Deeco's 90s-tastic webpage, it appears that before they went belly up in the late 90s, they were making computer products that had a similar form factor to the terminal we're working on today. They were color touchscreen devices running Pentium processors. And even when it comes to regular graphics terminals, they also made color versions. There's a version of the terminal with an LCD screen, not a plasma, but we still have a plasma one indicated what has a Lucas badge on it. The design features of the terminal include everything we've already seen, but also show that it has IP65 sealing, so there must be some gaskets around the components. A wide variety of displays including TFT color, sunlight readable color LCD, Paperwhite 256 shade LCD, and monochrome EL, which is going to be the plasma screen, for extended temperature areas. And there's the data sheet. Even this one could come in EL monochrome, which is what we have here, or trans-reflective LCD. There's the ST220 we're working with today, standard model, but there was a stainless steel version as well. Extended temperature model from -25 to 60. Various DC powered models and rear conduit cover kit, plus the Touch Assist 2 touch interface development software. And then this is that keyboard interface cable that would go from that odd 4-pin connector on the back to a regular 5-pin DIN. Luckily, it appears that Touch Assist 2 software, 17 kilobyte zip, is available. It's actually an EXE that downloads. And this is the PDF for that program. And look at it, it looks like a Windows 2.1 program, but it does say down here that it is Windows 3.1 compatible. Of course. We'll have to give that a try later in the video. All right, let's get back to the terminal and see what we can figure out about it.
So let's switch over to the other unit. I'm just gonna pull the power cord out of this one. And I'll get this one powered up. Let's see what happens. Okay, LED comes on. Certainly don't see anything on screen. By now we would have had a flashing cursor up in the top corner. Now I'm curious, let's see if we can bring up the menu and touch some keys. Yep. Okay, well remember that the touch screen is separate from the screen, right? Because it's in the bezel of the screen itself. So the plasma screen could be non-functional, and yet we still have obviously an operational terminal because we have keys that are working, but we just have nothing on the screen. So that pretty much confirms that either we have a failed plasma screen on this unit or there's a power supply fault. Now, considering these things come from the 90s means that there's a good chance that we have leaky caps. So that could easily mean that we just have to repair the power supply and the high voltage supplies that go to the plasma screen, and then this thing will work again. First thing we got to do though is open it up. It does say down here on this sticker, do not open, hazardous inside. We're gonna need to find the right, looks like Allen keys that open this up. Okay, that's impossible. Okay, all right, one of them came out. Let's see, is it Loctite on there? Nope, no thread locker. All right, going around this thing, these two are in so tight that that one started to strip. That one feels like it's going to, but it didn't yet. Oh, that one too is ridiculously tight. Oh, come on. It doesn't make sense. So all of these are incredibly tight, so much so Okay, there we go. I couldn't even budge it. I think I'm gonna maybe resort to some heat, although that's gonna be difficult because this thing is a massive heat sink, obviously. It is already partially open though, if you take a look there. So there's a rubber gasket and I don't wanna potentially damage that. You know, that has me thinking, maybe I just need to stand on the back of this, which will push down on the gasket. Maybe that's the pressure that's causing this issue. Okay, standing on that did absolutely nothing. I'm gonna maybe put a couple of these fasteners back in on the other side just to hold the cover down. Okay, yep, heat, localized heat. At least got one of the fasteners out. And this case dissipates the heat so incredibly quickly, but it seems to be doing the trick. Now on the bottom edge, there is something melted into this one, and then this one has a sticker over that fastener. I can feel it though, but I'll have to melt that one away, try to get it out of there. All right, all the fasteners are out. This is definitely coming apart now. Let's get this up on its end. What do we see in here? Looks like the screen stays attached to the back. All right, on the bottom edge, got some ribbon cables and other things. There are these springs, which seem to go from the back plate here, which I guess is the main controller board, to the front. And one of those screws is just floating around in there now. I think this cable is the plasma display. Let's try to get that out of there. Ah, yes, it was indeed. So this has come apart. Oh, there's another one though. Okay, that's wild. So these are thermal pads that touch every IC on the front display. Connect them to this case. Wow. My assumption is these ribbon cables are actually the front digitizer. There's the thermal, or there's the plasma display, and there is the other side of the digitizer. And now we have our look at the front of the unit. So check out the thick gasket all the way around. It's an O-ring style. Our display unit has a 1993 date code on it, March 18th. So I'm thinking about what to do here. The only thing that might be doable here is to completely disassemble the other unit and plug that panel into this machine and see what happens. Because certainly everything looks totally fine here. I don't see any like blown up components or any other issues. Although, well, you know what? The funny thing is, I think it's possible to run this with the ribbon cable that's connected to the panel plugged in. So maybe I can measure some voltages. I suppose something we can do is look for any shorts on this unit. So the tantalum, not shorted. And let's check these components. They seem fine. Totally fine. They are, let's see, 2N35, 2N35, and 2P50. So I assume an NPN transistor and a PNP. Same over there. So these could be shorted, but they are not. They seem fine. Yep, fine. Let's check this fuse. Should be shorted. It says it's open. Is that actually a fuse? A white package. I assume that's a fuse. Let's see if it's a resistor. 1 mega ohm. 1 mega ohm resistor. Is that possible? 1.8 mega ohms. 2 mega ohms. Interesting. I would think that's a fuse. I really would. Yeah, it appears to have 1 mega ohm on it. Another tantalum 35 volts. Does not have a short on it. You know, one would think that this panel has some somewhat high voltages on it. You know, not thousands of volts, but 50, 60, 70 volts, that type of thing. But it's not immediately apparent to me where those voltages might be. That's a 20 volt tantalum. And as I said, that's a 35 volt tantalum, looks like. Okay, let's take a look at the other half of this unit. So the power supply at the bottom. We need to kind of disassemble this further to get a lay of the land, but this is the cable that goes to the display. So theoretically, I could run the unit and we could measure voltages on here as well while this is actually connected. Now, my assumption of what's happening on this little blue board is that this signal cable comes from the main PCB, the computer part of it. And then notice this ribbon cable coming from this side of the power supply, which makes its way over to the small blue board, which almost certainly injects the extra power for the plasma screen into this signal cable. Now, flipping this little blue board over, I thought maybe we'd have something to look at when it came to voltage rails, but we do not. We can see that the voltages from this section of the power supply do make their way from just those traces over to the plasma cable. Sorry, that's out of focus a little bit. There's also a few traces on the top side as well. Now, on first blush on the power supply, when it comes to leaking caps, not really seeing any. I mean, unless they're leaking on the bottom side, things are looking pretty good. What sucks is nothing is labeled when it comes to voltage rails at all, though. That's lame. Seems this is made in-house. There's their logo on the board. Let's take these fasteners out and look at the other side. Maybe there are voltage rails written on there. Okay, yeah, that looks really good. I don't see any corrosion whatsoever. So those caps aren't leaking. Good quality stuff, I guess. They used super high quality Nichicons. And unfortunately, though, there are no silkscreen markings on the bottom that tell us any of the voltage rails. So that was no help at all. Part of me kind of assumes that this whole thing is like a cost is no object type of device. So everything is extremely, extremely high quality. Yeah, putting this back together, that's going to be a pain. I really wonder what mechanism they're using or they use to put this together with these washers. Okay, so the way this works is it's that washer first, then crush washer, and then this large flat washer. And I realize now that the correct way to take this apart was not the way I did it. I needed to take the nuts off those connectors on the back first. So let's get the power supply out of here. And the keyboard connection looks like it connects right here. So there it is. So I think what I'll do is I'll just put these fasteners back in a little bit so they won't fall out and spread their washers everywhere. So these nuts there have to come out. With those out, the PCB should be loose now. Yes, it is. Whoops. All right, there we go. These fasteners loosened. The main PCB is free. You kind of won't believe what I see under there. I need to be careful flipping this over because these fasteners, again, are going to fall out. Okay, there we go. Look at this. Oh dear. Oh, I thought this was a battery. It's a heat sink. Whoa. Wow, it's attached. It's sort of attached with a sticky pad to what I assume is the CPU. Or rather, no, it's the CRT controller. Fascinating, absolutely fascinating. So let's get a lay of the land. So we have some SRAMs, we got some ROMs, copyright Lucas 1990, Rev K. 1987 is the date code though on those. 28 256s, I'm assuming these are flash memory chips. More SRAM, which almost certainly has something to do with the CRT 7220A, which I think is the CRT controller. We have a Xilinx XC2018, which I'm thinking is a CPLD, and another one right here. And this chip is an Intel 8186. So there we go, Intel based. Even though this looks like a 286, it's not. It's more like an 8086, but with all these peripherals built in. To simplify systems like this, it just adds all those other Intel chips you require, DMA controller, interrupt controller, all that stuff is in this one IC. All right, so this looks like a serial controller, a synchronous serial controller of some type. This looks like Intel microcontroller. Perhaps this is used for the keyboard interface. There's pins for the connection to the touchscreen on that side, and they'll be the same over on this side. We have a few different unpopulated headers, maybe for like an expansion RAM module, an additional port that's not used. There is an installed pin header there that also isn't used, J8. This was the keyboard connection. I'm noticing that we do have some jumpers here and there, some kind of configuration thing, and look at those there. What's that all about? Why is that splayed out? Test points, maybe? Kind of odd. I'm noticing it says T, S, and A. So the T pin on the left, S in the middle, and A on the right. Also have another jumper over there, and a connector that was unused, 2-pin connector, maybe for an external speaker. And I don't see anything else that's too particularly interesting on this board. Nothing looks to be damaged. All looks absolutely pristine and perfect. Unfortunately, I put this thing down on the bench. This picked up a bunch of junk. These little tofu pads for the chips and heat sinks. I'm sure it's no big deal. Okay, well, I think maybe the thing to do now is to try to fire this thing up on the bench and see how that goes. I am heavily leaning to this screen being what's at fault. All right, so everything is really sketchy here, but I have removed the IEC jack from the back of the case. I really don't recommend doing anything like this. It's very dangerous with the power supply open like this. Of course, I will not be touching the heatsink or any of the power supply stuff with my bare hands while this is powered up. But I want to at least get this powered up enough to see if we have anything on the screen, which I'm sure we're not, but since I've jostled all the cables, maybe we have. And then I can start measuring voltages. Oh, interesting. I just noticed that the screen came out. It was sort of held on with a rubber gasket. Okay. But to be honest, I think all that holds it in is pressure from these pads on the back of it. I didn't take any screws or fasteners out for the screen at all. Okay, enough procrastinating. I have the mains power cord. It's not connected to the wall right now, so I'm going to plug this in. That way I can keep my hands away from this when I power it up. So we should be safe to power this up now. Here we go, 3, 2, 1. Okay, so we had some beeping coming out of the CPU. I bet you it's because the digitizer is not connected. I'm assuming we'd still have functional screen here if that were working. I think we're just in the same situation we were in before. All right, so I have this in DC volts. I'm going to clip onto this ground lead. And the ground lead actually is connected to the same ground lead that goes to the power supply. Theoretically, I'm thinking this should be 12 volts. Yep, 12 volts, looks good. And I'm just gonna see what voltages we see coming out of this going to the screen. -9, 10. That one must be ground. Must be ground. I'm just being careful not to short anything. Nothing. 5 volts. 0.12, that seems weirdly low. Is that 11 or -11? Looks like 11. 12. Yep, 12.2. Nothing. Nothing. 10. And minus barely anything. Not sure. I've unplugged the power cord, just so everyone is sure. It's just sitting right there. I'm going to unplug the signal cable that goes to the panel, and I'm going to check those voltages again. I want to see if they've changed at all. Not that I can remember exactly what we were looking at, but there was definitely nothing like 30, 40 volts, which I would kind of expect to see. Let's plug this back in. Sure, we're getting some beeping out of that. Yep, it's unhappy. Okay, here we go again. Very barely minus voltage there. That's weird. Nothing. Oh, this is weird. It's now really giving nothing. But let's check here. We should have 12 volts. Yeah, we have 12 going to the main machine. 5 volts. 2.7? Well, this looks a lot different. Not what I would expect. It's possible the power supply has... Oh, sorry, I've unplugged it. Just show you by leaving the cable there. It's possible this power supply has like a protection mode that when the cable's not connected to the panel, it doesn't power it up. I still feel that those voltages, though, seem too low for this particular panel. I just can't imagine this plasma panel can operate on just like what we see, 12 volts, and that was about it. Now, if you're thinking there's a DC to DC converter that is upping the voltage, you would expect to see inductors. And I don't see any inductors on this board whatsoever. So I don't think that's what's going on. All right, well, I'm not convinced here that the power supply is not at fault. So I think all there is really to do at this point is take the panel out of the other one and plug it into this and see if it works. And I'm not looking forward to that because of how tight the fasteners were holding it on. At least I know the trick to use heat to get this thing apart. So this is the second unit. And I realize now that the panel should actually stay connected to the bottom. When I took apart the first one, it seemed like the panel was actually kind of stuck based on the rubber gasket that's around it onto the front panel. But I knew better this time, so I just lifted it off this way and the panel stayed behind. All right, first things first, let's make sure this terminal still works. So I plugged it in and there we go. Okay, we're good, we're fully operational. Touchscreen, yep, there we go. Now, since taking apart the non-working unit, I was thinking about some of the aspects of it, and I came to the realization that this screen may not actually be plasma at all. If you notice in the photographs on Google Image Search where they showed some of these terminals, you could see through this front panel to the thermal pads that were underneath or behind the screen. So clearly for that terminal, someone had removed the display panel, which is kind of hilarious. Someone was trying to sell one without a screen. Like, it looked like it had a screen, but you could see the thermal pad, so the actual panel was missing. But I noticed that those thermal pads, when viewed through this front bezel or plastic, were very dark orange color, which kind of leads me to believe that maybe this is a vacuum fluorescent type display. And with vacuum fluorescent, which kind of has a cyan, light blue color, when you apply an orange filter to it, you get what looks like a plasma screen. And part of me has me wondering if the discoloration we're seeing on this panel is actually in the front plastic, which is what this is, versus in the screen itself. From the times I've used plasma displays, like on the various laptops I've had on the channel, it seems that when they're off, they're not actually an orange color, they're just sort of a gray color or a dark black. And when they're emissive, when one of the pixels is turned on, it's glowing orange, kind of like a neon lamp color. So that's just one of the other reasons why I'm questioning what's going on with this panel. Now, obviously for testing purposes, we have a working unit here, which has a working power supply and a working panel. The voltages were very strange on the other power supply, so much so that I'm kind of leaning towards the power supply on the other unit being the faulty component and not the screen. So the easiest thing for me to do is to simply plug this display unit with this middle cable into the power supply little blue board that supplies power and data signals to this board. And let's see if it comes to life. Obviously, I won't have the digitizer connected, so it'll still be using the digitizer that's on this unit, but I think that's a quick and easy test. The only thing I'm hoping is that this display isn't faulty in such a way that it damages the power supply on the working unit when I plug it in. But I don't think there's a whole lot I can do for testing. I already looked for shorts and nothing looked obviously out of sorts on this unit. So I think, yeah, that's the easiest thing to do is just use the ribbon cable from the other one. And let's plug it into the little blue board here. All right, cable's all connected up. I'll just rest the display there so you can see it. And I'm gonna plug the power cable in. Okay, here we go. 3, 2, 1. Ah, this display freaking works. Well, that's a good thing because actually I was concerned if the display itself was bad, how are we gonna fix that? This is a bespoke, unfixable part. And this tells us that it's the power supply on the other unit, or I suppose it might actually be the main logic board that's bad as well. Like maybe the video output's not working. But let's see, I should be able to get into, oops, that's not what I meant to do. I can get into the setup. Let's just see. This all looks the same. Yeah, I mean, it looks totally fine. Obviously we have that weird discoloration, but again, I think that's actually in this plastic on this unit. Okay, so there's actually a bit more testing we could do to see if it's really the power supply. We could plug this logic board into this power supply and see if it runs this screen. I think I want to do that test right now. So I have some mouse pads put down on top of the other screen. I'm just going to plug in the display cable. There we go, we're good for testing. So we'll see if this motherboard is working now with this. We should get an error code because the digitizer is not connected to the motherboard. No digitizer is connected to the motherboard. Let's plug this into the wall. Here we go. 3, 2, 1. self-test. Fail 04, and now we're at a flashing cursor. Great. So that tells us that this motherboard is working as well. And I think self-test 4 from the manual was, I think, IR digitizer or IR system or whatever it's called. So we know for sure the power supply in the other unit is at fault. Okay, so I have to say this is the best case scenario. The screen is good, the motherboard is good. The only thing that's faulty is this power supply. And I'm saying best case because I think the power supply is probably going to be one of the easier things to fix. We can see all the components that are on here and we can see all the traces that are on here. And that means we should be able to find replacements for whatever has failed on this power supply. And luckily when this failed, it did not damage the screen or the motherboard. I think I'm going to end this video here and leave any repair attempt for this power supply to a part 2. And once I get this thing working, which I hope I will, then we can really explore and take a look at this thing operating as a terminal. If for some reason I'm unable to fix this, don't worry. In part 2, I will at least put the working one back together again, and we can take a look at that one fully operational. I want to add one thing about the motherboard is I did take high resolution pictures of the front and back side of the motherboard along with the back side of the display, power supply, and the thermal pads. And while I was at it, I also dumped the EPROMs that are on this board. There are 3 of them, and the 2 EEPROMs. I tried to byte merge the EPROMs together for the system ROM, but I couldn't really make too many heads or tails of what was going on. I thought maybe there was some bit swapping going on with these EPROMs when they're connected to the CPU, but they're not. All 16 data bit lines go directly to the CPU correctly, well, through these LS245s. I think there might be some address shenanigans going on though. The data bus and address lines on the 186 are multiplex, so you normally need latches to hold onto the address lines, and then the data lines will go through these LS245s. I see one latch that's connected through to the CPU, but that's it. And one 8-bit latch is not enough for all the address lines that are needed for these ROMs and RAMs and the EEPROMs. So probably these PALs and maybe the FPGAs have something to do with that. Maybe they're remapping things and some shenanigans are going on. I'm going to upload all the photos and the ROM dumps to archive.org. I'll put a link in the description so you can check those out. It'd be really fun to understand what the system code is doing on here since it is x86. And I'm sure this ROM has to do with the microcontroller. Maybe that's for the touchscreen or keyboard or both or something like that. So yeah, take a look at that stuff if you're interested and good at system development, because maybe we could emulate this thing. And that actually would be pretty useful for people who use these with their old industrial machinery. If we could create an emulator, like a terminal emulator that could run on a PC, then you wouldn't need to have this super expensive thing hooked up to your machine. You could use something with a mouse and, well, cheap, like a Raspberry Pi. So anyways, if you've enjoyed this video so far, I would appreciate a thumbs up. If you have suggestions about how I can go about fixing this power supply, definitely let me know. I don't know a whole lot about repairs of things like switch mode power supplies beyond looking for the obvious problems, shorted components, blown up components, bad capacitors, you know, the usual stuff like that. This power supply obviously is kind of working to the point where the main system board is working. It's just the high voltages that the screen needs aren't being supplied. And I would like to give a huge thanks to my supporters. Names are going up the side of the screen. They make it possible I do this full time. Without their help, I wouldn't be able to do that. I have to get a normal job. So you can become a supporter down in the description below. You get some perks like early access to videos and some live streams and stuff like that. So I think that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.